Hello, this is not your chem tutor, and this video is part 1 of my tutorial on mole concept, where I teach you the basics of solving mass, moles, and number of particles using dimensional analysis. So in this video, I only included basic examples, so if you want to check out more tricky or more difficult examples, then you can check part 2, link is on the description. So let's start with the definition of mole. It is the amount of substance containing 6.022 times 10 raised to 23 particles. So you will encounter this number a lot in chemistry. This is called Avogadro's number. And Avogadro's number is equal to 6.022 times 10 raised to 23 particles per mole. Now, particles can be atom for single elements. It can be molecule for molecules. It can be ion for cations and anions, or it can be formula unit for ionic compound. So it depends on the nature of the substance. So for example, we have here 1 mole of oxygen. So when you say 1 mole of oxygen, this contains 6.022 times 10 raised to 23 oxygen atoms. So we use atoms because oxygen is a single element. 1 mole of H2O or water contains 6.022 times 10 raised to 23 water molecules. So we use molecules because water is a molecule. 1 mole K plus is equal to 6.022 times 10 raised to 23 K plus ions because K plus is a cation. And 1 mole of NaCl contains 6.022 times 10 raised to 23 NaCl formula units. So we use formula units because NaCl is an ionic compound. Again, when you say 1 mole of the substance, that is automatically equal to 6.022 times 10 raised to 23 particles. And particles can be atoms, molecules, ions, or formula units depending on the nature of the substance. Now, a lot of students get confused because they think that moles and molecules are just the same. They think that moles is just the abbreviation for molecules, but it is actually not. Moles and molecules are two different terms. So I will show you how they are different from each other. So let's take ethanol for example, C2H6O. When you say 1 molecule of ethanol, that contains 2 atoms of carbon, 6 atoms of hydrogen, and 1 atom of oxygen. So when you say molecule, the composition of the elements is in terms of atoms. When you say 1 mole of ethanol, that contains 2 moles of carbon, 6 moles of hydrogen, and 1 mole of oxygen. So when you say mole, the composition of the elements is also in terms of moles. So this is the difference between moles and molecules, and I want you to take note of this so you won't get confused when you encounter both terms. So let's start the calculations. By the way, we will be using dimensional analysis in all our calculations. So if you do not know how to do dimensional analysis, you can check the description box. I will put there a link to my video on the basics of dimensional analysis. So we will be converting mass to moles. And to do this, we need the molar mass. If you do not know how to compute the molar mass, you can check the description box. I will put there a link to my video. So example number 1, how many moles of water, or H2O, are in 20 grams of water? So basically, this example is asking us to convert 20 grams of water to moles of water. So we are given 20.0 grams of water. Again, what you need to convert mass to moles is the molar mass. So we need the molar mass of water. Luckily, it is given in the problem, 18.016 grams per mole. In case it is not given, you need to compute the molar mass on your own. So what does the molar mass says? It says that 1 mole of water is equivalent to 18.016 grams of water. So if you want to cancel the grams of water, you will put grams of water on the bottom, and on top you will put the moles of water. So according to the molar mass, 1 mole of water is equivalent to 18.016 grams of water. Grams of water will cancel, and the unit becomes moles of water. And if you type this in your calculator, 20.0 times 1 divided by 18.016, this is approximately equal to 1.11 moles of water. Don't get confused when you see mole without E and mole with E. They just mean the same thing. Let's try the other way around, converting moles to mass. So what we still need is the molar mass. What mass of HCl contains 1.50 moles of HCl? This time, we are given the moles of HCl, and we will convert this to mass or to grams of HCl. So we start with the given 1.50 moles, and we are given the molar mass, which is 36.458 grams per mole. This means that 1 mole of HCl is equivalent to 36.458 grams of HCl. So to cancel the moles of HCl, we will put moles of HCl on the bottom, and on top we put grams of HCl. And 1 mole of HCl is equivalent to 36.458 grams. Moles of HCl will cancel, and the unit becomes grams of HCl. And if you solve this, 1.50 times 36.458 divided by 1, this is equal to 54.687, and the unit is grams of HCl. And this is the answer to the question. Now let's convert moles to number of particles. This time, what we need is the Avogadro's number. 6.022 times 10 raised to 23 particles per mole. So example 3, how many molecules of methane or CH4 are in 0.750 moles of CH4? So we are given the moles, and we will convert this to molecules. So we start with the given 0.750 moles of CH4. Remember the definition of Avogadro's number? When we say 1 mole of CH4, that is equivalent to 6.022 times 10 raised to 23 CH4 molecules, since methane is a molecule. So to cancel the moles, we will put moles on the bottom, and on top we put CH4 molecules. So 1 mole is equivalent to 6.022 times 10 raised to 23 molecules. So moles will cancel and the unit becomes molecules. So if you solve this in your calculator, 0.750 times 6.022 times 10 raised to 23, this is equal to 4.5165 times 10 raised to 23 methane molecules. And this is the answer to the question. Let's try the other way around, converting number of particles to moles. So what we need still is Avogadro's number. So for example 4, how many moles of NaCl contain 5.66 times 10 raised to 23 formula units? So we are given the number of formula units, and we will convert this to moles. So we start with the given 5.66 times 10 raised to 23 NaCl formula units. And by definition of Avogadro's number, 1 mole of NaCl is equivalent to 6.022 times 10 raised to 23 NaCl formula units. So we use formula units because NaCl is an ionic compound. So if you want to cancel formula units, you will put formula units on the bottom, and on top you put moles of NaCl. So 1 mole of NaCl is equivalent to 6.022 times 10 raised to 23 NaCl formula units. So formula units will cancel and the unit becomes moles. And if you solve this in your calculator, 5.66 times 10 raised to 23 times 1 divided by 6.022 times 10 raised to 23, this is approximately equal to 0.940, and the unit is moles of NaCl. So this is the answer to example 4. This time, let's convert mass to number of particles. So there is actually no direct conversion from mass to number of particles. You need to do it stepwise. So what you do is convert mass to moles and then moles to number of particles. So we need the molar mass and Avogadro's number. So for example 5, how many carbon atoms are in 15 grams of carbon? So we are given 15 grams of carbon. You will convert it first to moles of carbon, and from moles of carbon to carbon atoms. So we start with the given 15.0 grams of carbon. According to the molar mass, 1 mole of carbon is equivalent to 12.01 grams of carbon. So grams of carbon will cancel out. Now we have moles of carbon. And by definition of Avogadro's number, 1 mole of carbon is equivalent to 6.022 times 10 raised to 23 carbon atoms. So we use atom because carbon is a single element. So the moles of carbon will cancel, so our final unit would be carbon atoms. So on top, we have 15.0 times 1 times 6.022 times 10 raised to 23 carbon atoms. And on the bottom, we have 12.01 times 1. And if you solve this in your calculator, this is equal to 7.52 times 10 raised to 23 carbon atoms. This is the answer to the question. Let's try it the other way around, this time converting number of particles to mass. Again, there is no direct conversion from number of particles to mass. So you need to do it stepwise. From number of particles, convert it to moles, and moles, convert it to mass. So what you need are Avogadro's number and molar mass. So let's try example 6. What mass of glucose C6H12O6 contains 1.05 times 10 raised to 24 molecules? So we are given the molecules of glucose, and we will convert this to mass of glucose or grams of glucose. So we always start with the given 1.05 times 10 raised to 24 glucose molecules. And by the definition of Avogadro's number, 1 mole of glucose contains 6.022 times 10 raised to 23 glucose molecules. So molecules will cancel. Now we have moles of glucose. And according to the molar mass, 1 mole of glucose is equivalent to 180.156 grams of glucose. So moles of glucose will cancel. So our final unit is grams of glucose. And if you solve this in your calculator, 1.05 times 10 raised to 24 times 1 times 180.156 divided by 6.022 times 10 raised to 23. This is equal to 314 grams of glucose. And this is the answer to the question. So let's just do a quick recap. If you want to convert mass to moles or moles to mass, you need the molar mass. Now, if you want to convert moles to number of particles or number of particles to moles, you need Avogadro's number. Again, there is no direct conversion from mass to number of particles. Instead, what you do is you convert mass to moles and then moles to number of particles. The same way as there is no direct conversion from number of particles to mass. So you need to convert number of particles to moles and then moles to mass.